Hi everyone, let's try some mathematical problem based on chapter 11 that will be helpful for your Sangha's homeworks. Uh, let's do all of our mathematical problem in Excel. Says chapter 11 cash cash flow estimation practice problem solution. Let's open it. Hmm, okay, now what is our problem? This is our problem. Okay, let's make it minimize. Okay, now okay, problem one. Say Talbot Industries is considering launching a new product. The new manufacturing equipment will cost 17 million, and production and sales will require an initial 5 million investment in net operating working capital. The company's tax rate is 25%. So problem one. Problem one. Problem one. Mm, equipment cost. So equipment cost is 17 million. And then net working capital, it should be changes in net working capital is 5 million. 5 million. Now tax rate is this. Tax rate is 25%. Okay, these are the information we have from our problem. I'm just making it color so that you can use for your problem if you see the different number. Okay, so what's the initial investment today? Part A. Part 1. What's the initial investment today? Remember from our class discussion, video, we said net working capital, if it is positive, meaning more cash outflow occur, and if it is negative, meaning more cash inflow occur. So we'll require another initial $5 million. So this is more cash outflow occur, meaning we have to spend it. We have to spend it. So $17 million we already spent, and $5 million additional we have to spend to make it functional. So that way we can get just summation of these two. Done. So this is our part A, meaning the initial investment. Okay, this maybe I should mark it as a different number, a different color. Okay, part 2, it says the company spent and expense $150,000 on research related to the new product last year. What's the initial investment outlay? So say R&D equal 150,000. So this is our R&D expenditure. We have these two information. Additionally, we are getting this. So now how much should be our initial investment? Think whether R&D is our sunk cost. We talked about sunk cost. Sunk cost meaning if one cost already spent, already happened, if you accept the project, if you do not accept the project, no way you can get that amount back. So if it is sunk cost, just ignore it. You don't need to consider about sunk cost. So additionally, I mean, uh, in spite of spending $150,000 on research and development, your initial investment would be the same thing, the equipment cost plus changes in net operating working capital. Okay, what else? Part 3. But rather than build a new manufacturing facility, the company plans to install the equipment in a building it owns, but it is not now using. The building could be sold for 150 million after tax and real estate commissions. What is the initial investment outlay? So the building sold is 1.5 million. So do you think we need to consider this building sold? Think of opportunity cost. If you if you do not use this building, you can use this building as your rent income or some other purpose. So since you are using this, you are selling this amount to fund this manufacturing facility, should we add it or not? Consider opportunity cost. Of course we should add. So this and this would be our now initial investment for this case, since we have opportunity cost. So this is the idea for problem 1. See problem 2. The financial staff of Cairn Communications has identified the following information for the first year of the rollout of its new proposed service. Consider um, project sales, operating cost, depreciation, and interest expense. But consider depreciation. What we talked about depreciation in our cash flow estimation, we said depreciation actually a deduction from the profit and loss account, but the actual cash flow did not happen. So in our cash flow estimation we should add it back. And then interest expense, since this is already taken care by cost of capital, so we should not touch or we should not consider interest expense in our cash flow estimation. Can you just copy and paste it in our Excel? Okay. Okay. On 9 million we should type it 18 million, then 4 million, and interest expense is nothing, 0. So then how we get our operating profit? Operating profit, we get this minus operating cost, sorry, this minus operating cost minus depreciation, 5 $5 million. And now we need to consider tax. I mean, we need to deduct tax rate. Tax at what percentage we have? 25%. Sorry. Negative tax, that's our 25% tax amount, or I should type here. This is our values we have from the problem, and these three we get from our problem. Okay, operating property, this tax amount, so this times this. Now what's our after tax profit? After tax profit equals this minus this. This is after tax profit. Now as we said, depreciation we need to add it back, so plus depreciation is what? This is our depreciation. Now net cash flow equals this plus this, 7 millions, I mean 7.75 million. This is our net cash flow. So in your problem, if you say different number, just say in this number. And interest expense is nothing. We don't need to consider. Okay, let's be three. P3. Okay, just read this one. We have we have a company, and the company has something that is, I mean, something meaning the milling machines that is old, but it is still functional, can run for next 10 years, but it is inefficient compared to the modern standards. That's why company is planning to replace it. The new replacement cost would be 110. The values, new machine cost is $110,000, and then number of years functioning would be 10. And then what else we have? An after tax cash flow. After tax cash flow is 19,000. Now cost of capital is 10%. Tax rate is 25%. So should send by the machine. I mean, uh, in other word, this problem is asking about to get net present value. If we know, if we remember from our chapter 10, uh, to accept or reject any project, we need to apply several capital budgeting tools and technique. Mostly used one is the NPV. So we can get it the NPV. How we can get NPV? NPV, if you remember, NPV equals PV of future cash flow minus initial investment. So see, so can I just get PV of future cash flow equals, say, FV rate. This is our rate. N per PMT is this. We need to make it negative to get the value positive. And then what else? PV, say, we don't know, 0, then type 0. So this is our present value of future cash flow. But now consider NPV. NPV equals this minus initial investment. So 192, 192,811 dollars. So NPV is the positive one. So do you think we need to accept the project or not? Oh, I'm sorry. It should be PV. PV. So now we have our NPV is this. So do you remember what was the criteria for selecting a project based on NPV? If you remember, NPV, if it is greater than 0, we should accept the project. If it is greater less than 0, we should reject the project. So our NPV is 6,746, so a lot. So definitely we should accept the project, meaning the chain company should replace its old machine by buying this one by $110,000. That's the idea. Okay, problem 4. Wendy's boss wants to use straight line 4 years. This is 1.7 million cost. Company could use 3 years macros depreciation, 4 years lifetime. This, okay, let me get the value. Initial cost of the machine, and you need to change this number for previous problem. Cost of the machine is 1, and then set timeline. 0 1 2 3 4. Tax rate 0.333. There's one more 3. 0.1234. This one is 0.4445. 0.1481. 0.074. And then cost of capital is 10%. Tax rate is 25%. This actually we have it. So then how much should be the what would be the depreciation expense by each year under each method? So we are talking about two methods: straight line and depreciation, the macros. So if this is macros, macros method, say straight line method. So straight line method first year would be how many? Just simply this by 4, 425. And this number would be the same for this. But what would be our macros method? So this times this. If you just fix it, so this is our macros depreciation. Okay, so this would be our two answer. Part 1, you need to select this as input, and this is this. Oh, this should be green. Okay, this is part 1. What about part 2? Which depreciation method would produce higher NPV? How much higher would it be? Actually, higher NPV. Mm, these the description of depreciation. Depreciation actually saves some tax. So if it is our 25% tax, we need to consider the tax saving portion. So let's consider the difference. Uh, difference some equal max minus straight line. So this minus this. So this is our difference. And how much would be our tax saving on this? Saving. So this times this rate, and we need to fix the rate. 35,402. If I just make it like this, so this would be our cash flow. If this is our cash flow, then how much would be our NPV? Say NPV equals NPV rate is our discounting rate, then value 16,902. So this is our NPV. So definitely NPV is our positive number. So macro should be the better one compared to the straight line. Part 3. Why might Wendy's boss prefer straight line depreciation? This is some kind of judgmental. We see if the company select macros depreciation method, there is positive NPV, that is 16 around $17,000. But instead of this positive value, why manager wants to choose this one? One reason is, if manager wants to get more bonus and bonus is tied to the net income, see first year net income would be reduced by $566,000, whereas if straight line the first year um, profit would be would be reduced by 4,2500 $425,000. So there will be more net income left, and if there is more net income left, then definitely manager will get more profit, that I mean more bonus. That could be the one reason. Then problem 5 is what, how many problems we have? So 5, 6 and 7. We have 3 more problems. Okay, since this is big, how long the video? Only 20 minutes, 22 minutes. Okay, let me give you the Excel spreadsheet for this 3 problems, 5, 6 and 7, and you need to understand how formulas are there, how the calculation done, so that you can customize it and you can use it for your Cengage homeworks. Thank you. Still, if you have any problem, let me know. I can work. Good luck.